Alright, let's add a new compose file monitoring YAML and include Prometheus and Grafana Docker images. We set the version in environment file as usual, and for Grafana we set the admin user and password for the dashboard as well as the open port 3000, which is the default port for Grafana. We also created a volume map to persist the changes we will do with this container. And for Prometheus we do the same, create a volume map for the data, and also a volume to pass the configuration of Prometheus. We will create this configuration file shortly. For port, we use 1990 for Prometheus, which is the default one. So remember we had 1990 reserved for gateways, but I will change it in the services YAML file to 1992 now. Note that we added monitoring YAML to the environment file in the compose file section so that with single docker compose up command, these containers will also be created. Now in config folder under docker compose folder, we will create Prometheus config, and then create the jobs by specifying the metrics URL there. For example, for query service 1, we set the target as query service 1 with port 8183. And use path actuator metrics, which is the exposed path we defined in configuration. We do the same for query service 2, analytics service, and Kafka stream service, as well as for gateway service. We also add Prometheus and Grafana itself to monitor them too. Great, let's now run the docker compose up command after being sure that all config server changes committed and pushed. If you open the localhost 1990 targets, which is the Prometheus targets page, we should see the all configured targets as up. Here in Prometheus we can also write queries to see metrics of services, but we will do that in Grafana to create nice dashboards. Let's now open localhost 3000 and log into the Grafana using the admin user we defined on docker compose file, and then create a new connection for Prometheus using a data source. Note that we need to use Prometheus as the hostname instead of localhost here, as we are in the Grafana container now, which requires the container name to communicate with Prometheus. Now we can create a new dashboard. First, I will add a new graph for Elastic Query Service 1 memory usage. And use JVM memory used by query and specify heap as the area. And then use job and ID in legend format to format the response on the graph for the chosen metric. Let's observe the last 15 minutes. I will then create a similar graph for query service 2. And then create request per second graph for query service also. This time we use HTTP server request second count and specify the correct URI. Again, I will create another graph this time for query service 2. Great, I will now make some queries. Let's do that from the web client. We should now see the changes for both memory usage and for requests per second in the graphs. You can use any metrics that Prometheus exposes here. I'm showing the most used ones as an example. Let's continue a bit. Now I will create average response time by dividing HTTP server request second sum to do HTTP server request seconds count. Let's create it for analytics service this time. Here we divide the total response time of request in a second to number of requests in a second to find the average response time per request. I'll then create process CPU usage for gateway service to observe the CPU usage of it. We can also create a graph to observe the logs. Let's use logback events total for each service and observe the error logs in a single graph. This could be helpful to see all errors in the system in a single graph. When we change it to info logs, we see some logs, but fortunately no error logs here. I will also add a gauge graph for JVM trace live trace metrics for gateway service. This time we need to use single stat instead of graph. By looking at the metrics endpoint, you can choose the ones that you want to monitor and then create graphs and tables on Grafana by using similar queries as we did here. Alright, we added monitoring option to our services. In the last section, we will add a correlation ID to our services and also integrate Logstash and Kibana to system to be able to monitor and search logs effectively on Kibana. I'll see you in the next section.